In this video, we are going to do converse of BPT. BPT we had already learned in the previous segment, right? So here we are going to do converse of that along with the important questions from the first exercise of the chapter as well as few important examples. That means in nutshell, today we are going to deal with BPT and converse of it. Okay. Now, starting with the converse of BPT's proof. So first of all, let's read the theorem. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Okay. Now, what are we given over here? That if a line divides any two sides of a triangle in the same ratio, means the line they are talking about is DE over here, and we are given that AD over DB equals AE over EC. This is what they have already given in the theorem, that it is this line DE is dividing the other two sides in a ratio. Okay. Then the line is parallel to the third side, means we are supposed to prove that DE is parallel to BC. This is what we are supposed to prove. Okay. So first, let's write down what is given to us. We are given that AD over DB equals AE over EC. This is given. And what are we supposed to prove? That DE is parallel to BC. Okay. Now, what I have done over here, first I had already made the figure, right? Now, there is going to be a construction over here. Draw DE dash. Okay. Now, what are we going to do? The proof. Okay. What is there in the proof, first of all? What is E dash? We will take, let E dash be a point on AC such that DE dash is parallel to BC. Okay. We are actually going to follow principle of contradiction. Principle of contradiction you had also learned in first chapter real numbers, right? Over here also we are going to do, because see, we know that E dash is not parallel. DE dash is not parallel to BC. But we are going to assume that so that we come back to the given thing which we are supposed to prove, which is DE. Okay. So if DE dash is parallel to BC, then according to BPT, what do we get? According to BPT, we get that AD over DB equals AE dash over E dash C, because BPT claims that when a line is parallel to one of the sides of a triangle, then that particular line is actually dividing the other two sides in the ratio. So over here we had taken that DE dash is parallel to BC. So we got this ratio because of BPT. Right. Now, we are given that AD over DB equals AE over EC. This is what we are given, right? Now, I'm marking this thing as first and this thing as second. And if you compare first and second, what are we getting? We are getting that AE dash over E dash C equals AE over EC. Now, what we are talking about, I'll just make a quick rough figure over here so that we can refer to it. This was E, this was D, A, B, C, and this was E dash. Now, what we are getting, that AE over EC equals AE dash over E dash C. This is going to be possible only if E and E dash coincide. And this is what we are supposed to write over here. This is possible only if E and E dash coincide. Coincide means they both are lying at the same point. Okay. So when we know that it is possible only if E and E dash is coincide, and we had already known that DE dash was parallel to BC. So therefore, DE is parallel to BC. That is all. When we are talking about converse of BPT, it is actually very easy. In BPT, yes, we have to do various things, but converse of BPT, we just have to take a random point E dash, assume it to be parallel, use BPT, and then at the end, we will say that it is possible only if E and E dash are coinciding, and hence DE is parallel to BC. This theorem is actually very easy to remember and practice upon. Okay, now moving on with the first example of the chapter. If a line intersects sides AB and AC of a triangle ABC, the figure is given to us. So we are told that there is a line DE which intersects AB and AC at D and B. Okay, and is parallel to BC. And we are also told that they are actually parallel. So I'm marking the points of parallel, right? These arrows always denote in figures that the lines are parallel. So now what do we get? We are supposed to prove that AD over AB. Now we are not talking about the segment of the line. We are not saying that AD over DB. But the question says AD over whole of AB equals AE over whole of AC. This is what we are supposed to prove here, right? So first, we'll start with the proof. We are given that DE is parallel to BC. So what do we get? Therefore, AD over DB equals AE over EC. And why do we have that? It is because of BPT. You have to write the reasons. It is normal geometry portion. So whenever you are finding something, you are concluding something, you have to write down the reason along with. Okay. Now, we have got the parts of the lines in ratio because of BPT. So what are we going to do? We are going to flip. We are going to do the reciprocal. उल्टा कर देंगे हम इसको. So we will get DB over AD equals EC over AE. We just flipped the ratios. And why did we do it actually? You will just realize soon. We wanted AD as it is, right? Now, adding one, sorry, it's not one, but adding one to both sides. That means we are having DB over AD plus 1 equals EC over AE plus 1. This is how we are supposed to add. Now, since we have added 1 to both the sides, we are supposed to take LCM. LCM in segments, LCM in lines, geometry. Yes, it is possible. So what are we going to do? DB plus AD whole over AD equals EC plus AE whole over AE. Right? Now, what are we getting? According to the figure, if I am adding DB plus AD, that gives us complete of AB. And similarly, EC plus AE gives us complete of AC. Right? So now, writing that on the next line, we get AB over AD equals AC over AE, right? Now, we'll just flip that again, and that gives us AD over AB equals AE over AC, and hence proved. See, this question is again very easy, but yes, there is a trick over here that once we have got the ratio from BPT, we had to flip it and then add 1 to both the sides. Flipping is important because we wanted AD on top. If you will not flip it over there, see what do we have? We had AD over DB equals AE over EC. This is what we had. Now, if I'm adding 1 over here, what we will do? AD plus DB over DB equals AE plus EC over EC. This is going to give us AB over DB equals, this is AB I have written, and this is AC over EC. We are not getting AD, we are not getting AE, right? The question wanted AD and AE, due to which we had to flip it, we had to bring them to the denominator so that when we take up the LCM, they do not get dissolved. That is the reason. This yellow section, I just did it to show what is the importance of flipping it in this particular portion. Okay, so now I'm erasing that part. Otherwise, this question is absolutely very easy, but yes, it is important as well. Okay, now moving on with example 2. What we have over here, that ABCD is a trapezium with AB parallel to CD. We are given these two lines are parallel of the trapezium. E and F are the points on the non-parallel sides, AD and BC respectively, such that EF is parallel to AB. Okay, now figure is pretty easy. It's just a basic trapezium. And then we have got a line which is again parallel to one of the parallel sides of the trapezium, right? So we are supposed to show that AE over ED equals BF over FC. This is what we are supposed to show, right? So what we are going to do for that? We are actually going to do a construction over here, right? Construction in the sense we are going to actually just a moment. Yeah, we are actually going to draw a line over here from A to C, right? Now, what does this line do? I will mark it a point over here as G. G is a point where it is intersecting EF. Okay. Now, starting with the proof. In triangle, okay, before we do for the triangle actually, what we need to do, we are given that AB is parallel to CD. We are given that AB is parallel to EF. So therefore, EF is parallel to CD. Why so? Logically we know, but what is the reason for it? There was a theorem in class 9th, lines and angles chapter, that if a line is parallel to a given pair of lines, then they all are parallel to each other, right? So we need to write that. We need to write that over here. A line parallel to a pair of lines makes, you can actually play with the words, but the meaning should be important. Okay. Line makes lines, makes all lines parallel to each other. Okay. Now, we will start with the triangle now. In triangle ADC. In triangle ADC. So we are talking about ADC. We're talking about this triangle. Over here, we know that EG is parallel to CD because EF, bigger line, was parallel to CD. That means a portion of EF, which is EG, is also going to be parallel to CD. So therefore, we have AE over ED equals AG over GC by BPT, right? I just did the proportion of the sides over here because of the parallel lines available, right? So we will mark this as 1. Now, we have used the triangle ADC as of now, right? Now, what are we going to do? We are going to use triangle ABC. Okay. In ABC, we have FG parallel to AB, right? So that is also going to provide us another pair of another pair of proportional sides, right? So let's start with that. In triangle ABC, right? So what do we have? We get GF is parallel to AB. So therefore, AG over GC equals BF over FC. Again by BPT. right? I have marked it as second. Why I have marked this as second and the previous one as first? Because if you compare, what do we see? We see that AG over GC and AG over GC is present in both the ratios, right? So when we are comparing 1 and 2, we get AE over ED equals BF over FC. So over here we will write from 1 and 2, we are having AE over ED equals BF over FC. And if you see, this is what we were supposed to prove, right? We just did a construction over here. Oh, that actually reminds me, we needed to write down construction before we had started the proof. You will write join AC and intersecting, you join AC intersecting EF at G. Guys, the way I had forgotten, yes, anyone can forget that. But whenever we are doing any construction, it is necessary, it is 100% mandatory to write down that in your solution as a part of your working. Okay. Now, I have written that. So first, we always write the construction and then we start with the proof. Okay. Now, so what did we do over here? We just drew a diagonal, right? And then we divided the whole trapezium into two triangles, used BPT in each of the triangles, and then just compared the ratios. That's all with this question, and hence it's pretty easy again. Okay. Now, again, example 3, we are yet to start with the exercise. But yes, these questions with respect to this second exercise, they are important. Okay. Now, what are we given over here? In figure 6.16, we have PS over SQ equals PT over TR. We are given that the ratio is equal. And then we are also told that angle PST equals angle PRQ. Okay. We are supposed to prove that PQR is an isosceles triangle. So first of all, we will write what is to prove. When they say isosceles triangle can mean two things. Whether you can consider that PQ equals to PR, or you can say that angle Q equals angle R. Now in this question, since they are talking about angles, I'll take, we are supposed to prove that angle Q equals angle R. And once we are done with it, that by default means it's an isosceles triangle. Okay. Now, we are supposed, what we are given over here? We are given that PS over SQ equals PT over TR, right? And then we are also given angle PST equals angle PRQ. We are given these two things, right? So, when we are given the sides are in the ratio, which theorem applies over here? It is a question belonging to converse of BPT. Because converse of BPT, हमें पहले ratio given होता है and उससे हम conclude करते हैं that the sides are going to be parallel, right? So, starting with the proof over here, since PS over SQ equals PT over TR, therefore ST is parallel to QR, and the reason that is going to come in the brackets is converse of BPT. This is the reason over here, right? We got the sides parallel, right? Now we are given that angle PST equals angle TRQ, right? I'll mark this one. Let's wait for this one. Okay. Now, since the sides are parallel, that means I'll mark this angle is supposed to be equals to this angle because of corresponding angles, right? So let's write down angle PST equals angle PQR, corresponding angles. I'll mark this one now, right? And then we are already given that angle PST equals angle PRQ, right? This is the second. Now, if you compare first and second that we have marked, PST equals PQR and PST equals PRQ. So we will write from 1 and 2, angle PQR equals angle PRQ. That means angle Q equals angle R. Hence, triangle PQR is an isosceles triangle. Again, a pretty easy question. These are all the questions which can range from 2 to 3 markers, right? Depending upon the length of the paper. Now, what did we do over here? We used Converse of BPT, got the lines parallel, proved corresponding angles, and then just compared the angles and got the desired result. So there were not many things that we had done over here that which makes this particular question again an easier one. However, they're all different categories of questions that I'm doing over here, and hence they are important. Okay. Now, this is a question belonging to exercise 6.2, question number 4. I haven't picked up question number 1, 2, and 3. 1 and 2 are pretty oral. They are just calculation based ratios, right? Question 3 is again easy, somewhat similar to this, but I find this more important question and hence I have picked it up. Now, the question says in the given figure, DE is parallel to AC. Okay, so I'll mark that DE is parallel to AC. Then we are told that DF is parallel to AE, right? I'll use a different color. DF is parallel to AE. Okay, now what are we supposed to prove? We are supposed to prove that BF over FE equals BE over EC. What we can see, the ratio that we are supposed to prove, they all belong to same length BC, right? So how are we actually going to do over here? And if we see, this whole figure is actually divided in so many triangles, right? So we have to understand how are we going to select the triangles, because it is going to be based on the given parallel sides. Okay. Now, what are we going to do over here? We are actually going to use in triangle. First, the parallel sides that we were given were DE and AC, right? So I'm going to use in triangle BDE and triangle BAC. That is the bigger triangle. So basically, first I'm using DE parallel to AC, right? Now, if we are having DE parallel to AC, this is given to us. So by convert, so it's not. So if lines are parallel, so we have by BPT, what do we get? We get BE over EC equals BD over DA, right? So by BPT, we get BE over EC equals BD over DA. I had marked those curves on the figure so that it becomes easier for you to understand that according to this triangle, we are using these portions of the lines. Okay, now I'm clearing that. Okay, now moving on further. We have used one triangle, right? Now, in another triangle. And the other triangle is going to be based on the other pair of parallel lines, which is DF and AE. So now, in triangle BDF and triangle BAE. That is, I am talking about this triangle, right? So what are we given over here? We are given that DF is parallel to AE. So by BPT once again. And every time you use BPT, you have to mention it. Okay. So by BPT, what do we get? We get BF over FE equals BD over dA. Now, this was first and this is second. And if you see over here, what do we have? BD over DA is present in both, right? So we get the remaining ratios being equal. So we'll just conclude our answer now. From 1 and 2, what do we get? We are getting that BF upon FC equals BE upon EC. This is what we get. BF upon FE, BF upon FE equals BE upon EC, right? This is what we get. Hence, proved. There was no trick involved in the question. We were given two pair of parallel lines. We used BPT twice and then just compared the ratios. Very easy, very preliminary kind of a question for the chapter. Okay. Now, moving on with the next one. This is question number 5. I had left the NCERT question numbers intentionally so that it becomes easier for you to refer. Okay. Now, the figure 6.20, we are given that DE is parallel to OQ and then DF parallel to OR. Though the figure is entirely different than the previous question, but conceptually it is same. Why? Again, we are given two pair of parallel lines. In the previous question, we were supposed to prove a ratio, right? Over here, we are supposed to prove that EF is parallel to QR. Okay. Which theorem helps us to prove lines being parallel? That is converse, right? Which means in this particular question, converse of BPT is going to be used. Now, starting with the question. First, we are given that DE is parallel to OQ. So, we are going to pick up triangle according to that. Now, in triangle POQ, what I have done? I have picked up this triangle because DE is parallel to OQ, part of POQ, right? In triangle POQ, DE is parallel to OQ. So therefore, we get PE over EQ equals PD over DO. This is by BPT, right? Now, what are we given next? DF parallel to OR, that is DF parallel to OR. So we are going to pick up in triangle POR. DF parallel to OR. So we get PD over DO equals PF over FR, again by BPT, right? Again by BPT. Now, the first ratio is marked 1, the second ratio is marked 2, and if you see over here, we have PD over DO common to both the ratios. Now, there have been so many questions we are doing where we are comparing, finding the common element. So the remaining elements are equated, right? From 1 and 2. What do we get? We get PE over EQ equals PF over FR. Now, but this is not the thing that we were supposed to prove at the end. What we have done, we have proved PE over EQ equals PF over FR. And we can see these two portions actually belong to the bigger triangle PQR. And what do we get? We get the two line segments of the bigger triangle in ratio. When we have got the two sides of one triangle in ratio, that means the line joining those 2 points are supposed to be parallel because of converse of BPT, right? So now we will just write that by converse of BPT. We have the lines are EF parallel to QR. I think it was Q1 only. Yeah, right. And this is what we were supposed to prove. So that's all. What did we do? We just applied BPT twice and at the end concluded the question with the help of converse of BPT. That is all, right? Now, moving on with question number 7. There is no figure in this question, but it says using theorem 6.1. 6.1 means BPT. Okay. Prove that a line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. Recall that you have proved it in class 9th. Guys, read the theorem and try to recollect. I'm sure you must recall that where did you use in class 9th. Meanwhile, I'll draw the figure. Okay, this is actually what we are doing. We are going to prove midpoint theorem that you had studied in class 9th quadrilaterals chapter, right? So what are we given over here? Prove that a line drawn through the midpoint of one side of a triangle parallel. So we are basically given that AD equals DD, right? And DE is parallel to BC. This is what is given. These two portions are equal and DE is parallel to BC. Okay. And what are we supposed to prove? Bisects the third side. That means we are supposed to prove that AE equals EC. See, I'm trying to decode the question in front of you by reading the line, writing what is given, reading the line, writing what is to prove, and if required, doing any construction. Otherwise, we are starting with the proof. Okay. And this is the pattern that you have to follow in your exams also, be it internal exams or be it the external boards. Okay. Now, starting with proof. So, we are already having that DE is parallel to BC, right? DE is parallel to BC. So, by BPT, what do we get? We get that AD over DE equals AE over EC, right? BPT provides us that if two lines are parallel in the triangle, then the one of the parallel lines divides the other two sides in the ratio, right? By BPT. Okay. Now, but the question provides us that AD equals DD, right? AD equals DD. So I am writing AD over AD equals AE over EC. And there is going to be a reason over here because I have changed one of the sides in the ratio because AD equals DB. So now AD will get cancelled, right? What are we getting? We get 1 equals AE over EC. So therefore, EC equals AE. And see what I have written over here to prove. AE equals EC. This is what we just proved, right? Hence, DE bisects the third side of the triangle. Why did I write in words like this at the end? It is always recommended that whatever the question asks, you conclude the final statement using those kind of or similar words. Okay. That actually shows that yes, you had understood the question. Mathematically, you also prove, and by the end, you are writing the conclusion in clear English words as well. Okay. So that's all with respect to this question. And now moving on with the next question, that is question number 9 of the second exercise. We do not have any figure again over here. The question says ABCD is a trapezium in which AB is parallel to CD and its diagonals intersect at a point O. Okay, so let's first make the figure. This is a trapezium, and then we are having the diagonals as well. Okay, now we'll label it we are given that AB is parallel to DC. Okay. One important tip over here, whenever you are making your own figure and you have to mark the points, please make sure that all the vertices of your particular shape, whether it's a triangle or quadrilateral or whichever, the points are in the cyclic order. See what I did over here when I say cyclic order, I marked A, B, and after B, I made sure that it is C and not D, right? Initially, you may feel that it doesn't matter, but when you flow with the while proving, things will go wrong, and that is 100%. Okay, so please ensure that when you are marking the points, they always maintain the cyclic order. Okay, now we had marked it, and along with that, the question said the diagonals are intersecting at a point O. Right? Figure is done, labeling is done. Now, what are we supposed to prove? That AO over BO equals CO over DO. We are supposed to prove about the ratio of the diagonals over here, right? First, what is given to us? We were given that AB is parallel to DC, and that's all, right? Nothing else was given. What are we supposed to prove? AO over BO equals CO over DO, right? Now, there is going to be a construction over here, right? And the construction is we need to draw a line parallel to AB. You can take it parallel to AB, or you can say that it is parallel to CD, and I will mark this as E point. So construction is draw, draw EO parallel to AB. I have taken it for AB. Now, starting with proof. Okay, starting with proof. First of all, we were given that AB was parallel to CD. Then we have EO parallel to AB, right? So therefore, we get EO parallel to AB parallel to CD. All lines got parallel to each other, the way we had done in one of the previous questions today as well, right? Now, we will start with the triangle. In triangle ABD, I am using this triangle. Okay, we have EO parallel to AB, right? So when EO is parallel to AB, what do we get using BPT? We get that AE over ED equals BO over OD by BPT. We are getting this by BPT. We use the triangle ABD and we got the respective sides in proportion because of BPT, right? Now, what is going to be the next step? And meanwhile, I'll mark this as 1. Okay, what is going to be the next step? EO is a small line we have not drawn for the whole trapezium. So EO is also a part of another triangle. EO is a part of triangle ADC as well, right? Now, when EO is parallel to CD, we get these two sides also in proportion. Okay, so we are going to use that. In triangle ADC, EO is parallel to CD. So therefore, AE over ED equals AO over OC by BPT. I have been writing BPT so many times that now P wants to skip out. Okay, so we get AO over OC. Okay, so this is the second point. Same pattern that we are doing. We do something with BPT, we do another thing with BPT, and we compare the ratios. So same pattern yet again. Because if you see, what did we get? We get AE over ED being a part of both the ratios, right? So that gives us from 1 and 2, we get BO, I think it was BO on top, yeah, BO over OD equals AO over OC. Are we done? No, we are not done. Very slight thing left. Because if you see, what they had asked AO over BO, right? But what we are getting is a different ratio altogether, right? What we need to do, we need to just crisscross. We need to replace them. Not both of them, but only one of them. So we get OC over OD equals AO over BO. And now we are hence proved. We are at the stage where we can write hence proved. Because see, though, yes, what we had done over here till this point, it was also proving it. But it was not the exact desired result what the question had asked. And if you just leave your answer till that particular point, you will lose half mark. यार सब कुछ कर दिया, इस चीज को लिखने में क्या फर्क पड़ता है? Why to lose that half mark as well, right? So do take care of that point. आपको यहाँ पे रेडीमेड ये वाला रेशियो कभी नहीं मिलेगा इस क्वेश्चन में, ये नहीं मिलेगा. आपको लास्ट में हमेशा क्रिस क्रॉस करना ही पड़ेगा इसके अंदर. सो प्लीज इंश्योर दैट यू डू इट and do not lose that half mark unnecessarily. Okay. Now, the last question of this exercise and this video as well. The question says the diagonals of a quadrilateral ABCD intersect each other at a point O. Okay. Now we are given that there is a quadrilateral. The diagonals are intersecting at a point O such that A over BO equals C over DO. Show that it's a trapezium. Okay. It is just the converse of the question number 9 which we just did. यहां पे हमें रेशियो गिवन है, पिछले क्वेश्चन में हमने रेशियो प्रूव किया था. In the last question we were given it was a trapezium. Over here we are supposed to prove it's a trapezium. In the previous question we were told the lines were parallel because it was a trapezium. In this question we will prove the lines are parallel and hence it's going to be a trapezium. तो हुआ ना बिल्कुल कन्वर्स, राइट? बट फिगर सेम बनेगी, एब्सोल्युटली सेम. सो लेट्स जस्ट क्विकली मेक दैट फर्स्ट. And we got the figure. It is A, B, C, D, O, and we will have a construction again over here. Let it be point E. Okay. तो सारा कुछ same होगा. That means first we are having what is given. Yes, given is different actually over here. To prove is different, right? So given में हमारे पास है we have AO over BO equals CO over DO, right? What we have done? Construction. Draw EO parallel to AB ले लिया. Okay, I'll mark the arrows. Then we are supposed to prove. अच्छा, अब question says show that ABCD is a trapezium. We cannot write, when we are writing to prove, over there you have to write in the mathematical notation and not the words show to prove ABCD is a trapezium. No. But mathematically trapezium proof करने के लिए हम क्या करेंगे? We need to prove that AB is parallel to CD. Once we are done, then we will end the answer that hence ABCD is a trapezium. And हम वहीं पे करेंगे, but पहले हमें मैथमेटिकल नोटेशंस रिप्रेजेंट करनी होती हैं. ओके. नाउ स्टार्टिंग विद द प्रूफ. ओके. इन दिस क्वेश्चन we do not have initially that AB is parallel to CD. तो जो हम पिछले क्वेश्चन में हमने लाइंस का किया था that EO is parallel to AB is parallel to CD, that will not take place. I am comparing the two questions time and again so that you understand the difference in both the questions. Okay. Now what we have over here, EO is parallel to AB, right? So in triangle ABD, what do we get? We get AE over ED equals BO over OD by BPT, right? This is marked as 1. Very simple thing. I picked up triangle ABD, right? EO was parallel to AB. So the sides got in proportion by BPT. Simple, nothing complex here, right? Up. What we have? We are having this ratio. But over here we have BO over OD और यहाँ पे BO और OD are on different sides. So see what we are going to do now. AO over OB equals OC over OD. This is given. We are going to turn this according to our requirement. AO over OC equals OB over OD, and this I will mark 2. Because if you see, we have got OB over OB over OD common in both the ratios, right? So again comparing the two ratios from 1 and 2. Okay, what do we get? We get AE over ED equals AO over OC. Now coming back to the figure, we got AE over ED equals AO over OC. दो sides ratio में आ गई. When the two sides are in ratio, converse provides us that the lengths are going to be parallel, right? So we will write down by using converse of BPT, we get that EO is parallel to CD, right? We knew EO was parallel to AB. So therefore, EO becomes parallel to AB, parallel to CD. That is AB parallel to CD. हमने टू प्रूफ में ये लिखा था that AB has to be parallel to CD, and this is what we proved. Hence, ABCD is a trapezium. Conclusion by writing this line is must. It carries half mark. It is necessary. Okay. What did we do in the question? There were two things involved. First, we did BPT. Then we actually changed the given ratio according to the requirement, compared the ratios, used converse of BPT to prove lines being parallel, and hence we got the desired quadrilateral as a trapezium. That's all. So in this video, I have actually summarized all the questions from NCERT with respect to BPT and converse of it, right? Do watch it carefully and do practice well. Like this chapter carries weightage. Do practice all the NCERT questions carefully, each and every example, each and every question before you jump on to any other book. Okay. So that is why I had covered NCERT over here. And soon you will be getting the videos from the important questions with respect to other books as well. Happy learning.